In this video, I want to have a look at a few more concepts to do with the equations of straight lines. So first off, I want to have a look at finding the equation of a line if we know its gradient and we know one point that it passes through. So if we know the coordinates of a point that it passes through, we know that it has a gradient m, then we can use this formula here, which is on your formula sheet, and we can have y minus y1 equals m outside of x minus x1. Then we'll simplify that down, and that will be the equation of our line. So let's have a look at an example. So our example asks us to find the equation of the line with gradient 2/3 and passing through the point 1 minus 4. It also asks us to write our answer in general form. So we've got this formula here. This point here is going to be our x1, our y1, and our m, our gradient there. So we'll substitute all of those things in. So we'll have y minus minus 4 equals 2/3 outside of x minus 1. Now we'll simplify this double negative here. So we'll have y plus 4 equals 2/3 outside of x minus 1. There's a few different things we could do here. The first thing I think, first instinct some people will have is to multiply out that bracket, so expand it out. And you can do that, but because we're trying to write our answer in general form, we know that we don't want any fractions in our answer at all. So what we might do instead to make it a little bit nicer is multiply everything through by 3. So we're going to have 3y plus 12 is equal to 2 outside of x minus 1. Now if we expand our bracket out, we'll have 3y plus 12 is equal to 2x minus 1. And then to put this in general form, we need to put everything over one side of the equal sign. So we'll have 0 equals 2x. Oh, sorry, and the reason I'm pulling it over this side, so pulling it all to the right, is because we want our x term to be positive, and it already is. So that means we're going to pull all this over to the right-hand side. So we'll have 2x minus 3y, and then minus 1 minus 12 will give us a minus 13. Oh, sorry, hang on. That should be a 2 there, because when I expanded that out, which would make this here a minus 14. Okay, so that is the equation of our line with gradient 2/3 and passing through that point there. So next I want to have a look at how we can find the equation of a line if we're given 2 points that it passes through. So it's going to be very similar to our last example, except we're not given the gradient. So the first thing we're going to do is find the gradient of a line that passes through those 2 points, and then it's going to be exactly the same as the example that we just did. So to find the gradient, we know that m is equal to y2 minus y1 over x2 minus x1. Now remember, it doesn't matter which ones you use as y1 and y2 and x2 and x1, as long as you're consistent. So if we go 1 minus 7, then we need to do it in the same order. So we'll have 6 minus minus 2. So 1 minus 7 would give us minus 6, and 6 minus minus 2 would give us 8. And if we simplify that down, that would give us minus 3 over 4. So our gradient is minus 3/4. So the point gradient form of the line is y minus y1 equals m outside of x minus x1. Oops. So we know now our m is that minus 3/4. It doesn't matter which point we use for our y1 and x1. I might go with this one just because they're both positive numbers and they're often nicer to work with. So let's go y minus 1 equals minus 3/4 outside of x minus 6. Now it hasn't told us whether to write our answer in general form or point gradient form, but because of this fraction, general form is probably going to be a little bit nicer. So I'm going to multiply everything by 4. So we're going to have 4y minus 4 is equal to minus 3 outside of x minus 6. Now I'm going to expand out this side. So 4y minus 4 is equal to minus 3x plus 18. And then we need to move everything to one side of the equal sign. Because we want our x term to be positive, we're going to move all of this over to the left-hand side this time. So we'll add 3x on. So we'll have 3x plus 4y. And then we're going to subtract 18. So minus 4 minus 18 would give us minus 22 is equal to 0. So that's the equation of the line passing through those 2 points. The last concept I want to look at today is something called concurrent lines. So if we have 3 or more lines, they're concurrent if they pass through the same point. So to check whether three lines are concurrent, we're going to pick two of them, and it doesn't matter which two. We'll solve them simultaneously to find their point of intersection, and then we're going to substitute that point of intersection into the third line and see if it makes sense. So see if that point lies on that line as well. So with this example, we've been given the equations of three lines, so line 1, line 2, and line 3, and asked to see if they're concurrent. So we're going to solve two of them simultaneously. Like I said, it doesn't matter which two you pick. For now, let's pick lines 1 and line 2. So if we have x minus y plus 4 equals 0 as our first equation, and x plus 3y minus 20 equals 0 as our second equation, it's probably going to be easiest to solve those by elimination. So to get rid of these x's, we'd have to go equation 1 minus equation 2. So that would eliminate out our x's. Minus y minus 3y would give us minus 4y. And 4 minus minus 20 would give us positive 24 is equal to 0. And now we're going to go through and solve that. So we'll subtract 24. So we've got minus 4y equals minus 24. And then divide through by minus 4, and we'd end up with y equals 6. So that's given us our y coordinate, but we need our x coordinate as well. So we're going to substitute that into one of these. Again, doesn't matter which one. So let's sub y equals 6 into that first equation. So we're putting it in here in line 1. So we're going to have x minus 6 plus 4 is equal to 0. So we've got x minus 2 is equal to 0, which means that x is equal to 2. So the point of intersection has coordinates 2, 6. So we know that both of these lines pass through that point, and that's the only point that the two of them pass through. Now we need to check whether this third line also passes through that point. So in line 3, we're going to substitute in 2 and 6 for x and y. So we're going to have 4 times 2 minus 6 minus 2, and we're hoping that that's going to come out to give us this 0 on the other side of the equation. So 4 times 2 is 8, 8 minus 6 minus 2. Now 8 minus 6 is 2, minus 2 gives us 0, so that means they are concurrent. So therefore concurrent. Okay, so that's a few more examples of concepts to do with the equations of straight lines.